Good morning, evening, or afternoon to all that are listening. My name is Tristan Stevens, and I would like to talk about solar radiation. Now, why did I choose this topic? Well, I wanted to learn more about what we covered about this topic, and I also found it funny to do because I barely go outside. One of the first things we covered, and a fresher is always nice, and especially when it has new information. So, what do we currently know that we've discussed in class? Well, solar radiation is radiation from the, sun, also known as sunlight. Solar radiation is variable on location, time, season, landscape, and weather, such as like places near the equator remain consistent with the temperature. So, if you look down at Ecuador and Chile, that would be one of the many places. I believe the temperature there stays consistent at 63 degrees, which is 7 degrees Celsius. And then finally, we know that it emits UV, also known as ultraviolet rays, and those cause harmful effects to our ozone layer and also to us humans, such as the very obvious cancer, which nobody particularly enjoys. I've learned a lot more after doing about an hour's worth of research, such as the sun is a variable star and Earth is a sun powered planet. The Climate of Radiation Lab are the main researchers about solar radiation. 1978 was the main year that we began researching solar radiation via satellite. And then what total sun irradiance, TSI, is and is the integrated solar energy arriving at Earth. Variable star, the sun. So the sun is a variable star because the brightness and energy activity has been changing for about 11 years, driven by the magnetic activity. The solar cycle, not system, that's what we all are in. The solar cycle is about an activity that waxes and wanes, which just means goes up and down in an 11-year cycle. The solar max is periods of high activities with many sunspots, so that's where you find your higher temperatures and years and like your summer months. And then solar minimum is the exact opposite of that, which is periods of low activity. So that means fewer to no sunspots. So that's where like our winter months come in, and like our very chilly, like native 23 degrees. And then moving on to Earth, I also learned that Earth is a very sun-powered planet. And now, sun-powered planet means like it nearly all the energy on Earth comes from the sun. We look at photosynthesis as it's an integral part to solar radiance is needed for plants to undergo photosynthesis. And also, solar radiance plays a heavy part into the water cycle, which in turn like leads to evaporation. How quickly, like what temperature does snow melt and become rain, or does it not melt and become snow? It's everywhere in the world that we need it. I mean, we've got our bodies are coded to obey the solar radiance cycle, the sunlight, and also we have like solar panels and all that fun stuff. The Climate of Radiation Lab, it's a NASA lab, and it focuses mainly on the aerosols impact climate by reflecting or absorbing sunlight. And aerosols are minute solid liquid particles suspended in the atmosphere, which is either natural, like sea salt or water cycle, etc., or man made, that would be like your smoke, that would be like burning fossil fuels and all of that. Composition of smoke and gas would rise. And then the Climate of Radiation Lab's main goal is to understand Earth's climate on all time scales, and like try and predict how to respond to future drivers of change. Like, for example, fossil fuels, like if we develop something more pollutant than that, how to like combat it to prevent worse things from happening and letting more solar radiance in. November 1978, what made it so significant? So in 1978, November, Nimbus 7 was a satellite and was launched, which started the first continuous space-based reading of TSI for the first time. And it provided like a foundation to what where we are today for solar radiation studying. And it also revealed that the solar constants aren't actually constant, but rather varies over 11 years, which is absolutely hilarious because you can imagine someone studying the solar radiance back then being like, huh, it's been the same weather for this amount of time, it must be consistent. And once they got the results back from this satellite, Nimbus 7, they're like, oh, it's actually not consistent or constant in the slightest bit. It's an 11-year span. And then going back to TSI, total solar irradiance, it measures sun's energy outreaching Earth. It's measured in watts per square meter, so that would be W over M squared. And more recently, in December 15th, 2017, NASA launched TSIS-1, which was designed to last about 5 years to study. And this found that there was improved spectral stability, lower trend uncertainties compared to previous instruments, like, for example, Nimbus 7, which was about 52, no, I would say 57 years. No, not 57, 59 years, pardon me. And then some final questions to leave off. Why is the sun considered a variable star? What does the Climate of Radiation Lab do? What was the satellite sent on November 1978 called? And finally, what is TSI? Thank you for listening to me ramble about solar radiance and about some of the things I have discovered during my research about it. Bye.